Now we come to the second law, Newton's second law. I have a spring. Forget gravity for now, you can do this somewhere in outer space. This is the relaxed length of the spring, and I extend the spring. I extend it over a certain amount, certain distance, unimportant how much. And I know that when I do that, that there will be a pull, non-negotiable. I put a mass m1 here, and I measure the acceleration that this pull causes on this mass immediately after I release. I can measure that. So I measure an acceleration a1. Now I replace this object by mass m2, but the extension is the same. So the pull must be the same. The spring doesn't know what the mass is at the other end, right? So the pull is the same. I put m2 there, different mass, and I measure new acceleration a2. It is now an experimental fact that m1 a1 equals m2 a2. And this product, ma, we call the force. That is our definition of force. So the same pull on a 10 times larger mass would give a 10 times lower acceleration. The second law I will read to you. A force action on a body gives it an acceleration which is in the direction of the force. That's also important. Acceleration is in the direction of the force, and has a magnitude given by ma. Ma is the magnitude, and the direction is the direction of the force. And so now we will write this in all glorious detail. This is the second law by Newton. Perhaps the most important law in all of physics, but certainly in all of 801. F equals ma. The units of this force are kilograms times meters per second squared. In honor of the great man, we call that 1 Newton. Like the first law, the second law only holds in inertial reference frames. Can the second law be proven? No. Do we believe in it? Yes. Why do we believe in it? Because all experiments and all measurements within the uncertainty of the measurements are in agreement with the second law. Now you may object, and you may say, this is strange what you've been doing. How can you ever determine a mass if there is no force somewhere? Because if you want to determine the mass, maybe you put it on a scale. And when you put it on a scale to determine the mass, you make use of the gravitational force. So isn't that some kind of a circular argument that you're using? And the answer is no. I can be somewhere in outer space where there is no gravity. I have two pieces of cheese. They are identical in size. This is cheese without holes, by the way. They are identical in size. The sum of the two has double the mass of one. Mass is determined by how many molecules, how many atoms I have. I don't need gravity to have a relative scale of masses. So I can determine the relative scale of these masses without ever using a force. So this is a very legitimate way of checking up on the second law.